All right, so the next short video I have here is about logarithms, okay, because everybody loves logarithms. Um, and one is just the relationship between exponential stuff and logarithms, okay? So by kind of our definition for logarithms, if the log base b of a equals y, okay, what that means is that b to the y has to equal a. This is the base of the exponent. Okay. This is the exponent, and the other number is just what it's equal to. Okay, so by definition then, if we have log base 2 of 8, this is going to equal 3 because 2 to the third is equal to 8. Logarithms and exponentials are inverse functions. They just undo each other, just like squares and square roots are inverse functions. They undo each other. Addition, subtraction, multiplication, division. But it comes in real handy to be able to switch back and forth between exponential notation and logarithmic notation. Okay, so these couple questions are designed just to help you practice that. Now, E in natural log is kind of special because natural log is just nothing but log base E. Okay, so when I see e to the y equals 4 and I want to write that as a logarithm, then that's going to be log base e, because the little number down there is the base of the exponent. The number that's beside it is what the exponent's, what it's equal to, and the exponent out here. So we have log base e of 4 is equal to y. Now, since log base e is special, we write that as the natural log. So this would be properly written as natural log of 4 equals y. And you should be able to go back and forth. So when I see natural log of x equals 5, first thing in my mind I'm picturing is log base e of x equals 5. I like to see it this way because, I don't know, it arranges the numbers in a pattern that I recognize a little better. So that's going to be e to the 5th is equal to x. Because remember, the e is the base, this number is the exponent. Okay. All right, so that's your basic definition stuff for a logarithm. Now, logarithms have some really nice properties, and you'll come across questions that look like this, but before answering those, I want to talk about the properties a little bit. But let's go back and review real quick. If you have two numbers that have the same base, so let's just call it x, and you're multiplying those, but they have different exponents. What do you do with the exponents when you're simplifying? If they have the same base and you're multiplying, you add the exponents, right? So the property for the logarithms is the same thing, because remember, a logarithm is an exponent. Okay? So we said the log base something of 4 is equal to the exponent. So the connection is that if you are multiplying things that have the same base but different exponents, you add the exponents, right? If you are adding, logarithms and they have the same base, like in this case, our example over here, what do? Okay. You would multiply these things. So this would be log base 4 of 3 times 7. Okay. So notice really what we're doing, we're adding the exponents that is something that we're multiplying together when we think about the bases. Okay, so you can simplify this, and that would be log base 4 of 21. Okay. You can do this forwards and backwards. If you have log 4 of 3 times 7, you can always split that up from multiplication to addition. Okay. Same thing with subtraction. When you are dividing things that have the same base, you subtract the exponents, right? So if you're subtracting exponents, you would need to divide with those. So by the same token, if we have log base 9 of something minus log base 9 of 7, and that equals log base 9 of 8/7, the question is, what are we dividing here? It's 8 divided by 7, so that would be an 8 in this little block. Okay? And yeah, it's highlighting things it ain't supposed to highlight and doing other kind of goofy stuff. There we go. Okay? So when you're subtracting logarithms, you can combine them together, and if it's subtraction, you divide. Okay? If you already have the division and fraction, you can always split it up, kind of by working backwards. And a very, very similar rule would be, remember, if you have something to an exponent raised to another power, okay, what do you do with those exponents? You multiply those exponents together, so that'd be x to the 10th. Okay. With the logarithms, that's the same kind of thing. Okay, we're multiplying two things here. One of those, we have a 3 times the log base 6 of 3. Well, log base 6 of 3, remember that whole thing is an exponent, right? So if I write out the in-between, log base 6 of 3, 3 times that would be log base 6 of 3 to the third. It's like having an exponent to an exponent, because we're multiplying those things together. And then, of course, 3 to the third is 27. So that would be log base 6 of 27. So these logarithm rules are actually still the exponent rules. They're just written a little bit differently because we're talking about the inverse functions, but they still have kind of the same relationships. When you're adding exponents, right? When you're adding exponents, you're multiplying the bases. If you're adding exponents, you're multiplying here. If you're subtracting exponents, that equates to a division type of thing. And an exponent to an exponent is a multiplication. Okay? The other types of properties is you get questions like this where you use those properties to go backwards with it. So when I look at log base y times x to the 9th, I notice it's y times x to the 9th. And since we're multiplying those, we could split that up into addition. So that's log base y times log base x to the 9th. Okay. Now, log of y, ain't nothing we can do with that. But since we have x to the 9th, I can bring that 9 down in front and change it to a multiplication thing. And that's what it's looking for, where you have the log of just one little variable running around, and you could be adding, subtracting, things like that. But I don't know, it helps me a little bit to see the similarities between the exponent stuff and the logarithm stuff to help remember these rules, just because I knew the exponent rules pretty well by the time I got to this stuff. So hope it helps a little bit. If not, let me know, and I will certainly endeavor to do a better job. So just holler if you need it.